In this video, we are going to understand the real meaning of cross product of two vectors. So let's consider two vectors, A and vector B, and what will be the cross product if we have to express them as another resultant vector. All right. So if A and B are two vectors in a single plane, or if we can plot them on a single plane, then your A cross B, which is the resultant vector, is perpendicular to both A and B. How can we explain this? How can we understand this? Right. Now let's consider a spanner which is used to unscrew this bolt. How would you do that? So you have the bolt and you have the spanner holding the bolt. Then you have a hand that's going to use its force on the spanner, and that force is going to start to rotate the bolt, and the resultant would be the bolt would unthread and come out, or you can tighten the bolt. Right. So I'm going to define this spanner, this long spanner, as vector A. Just to note that if I'm going to reduce the length of the spanner, then the efficiency of the work done is going to be reduced. I think that's simple logic. We all know that. So the longer the spanner, the more easier it is for us to get the bolt out of place. Now, so the vector A, its length is very, very important. Then we have the hand, which is our second force, which is acting. If you notice, the action of the hand is not in the same line as the spanner. You're not going to push the spanner in this direction, but rather you're pushing it almost 90 degrees or 80 degrees or 70 degrees. So it's an action which is, not in the same direction as A. So I'm going to call that as vector B, which is acting in this direction. So let's consider they are in a same plane, vector A and vector B. Now the resultant would be, we all know, the bolt will begin to unscrew. Why? Because at this point, the spanner is going to have a rotation. It's going to rotate. So that is our resultant force using these two vector A and B. So it's going to be a circular motion, and the circular motion is going to impact the bolt, and the bolt is going to unthread itself and start to come out. So you can narrate this using the right-hand rule for curve orientation. What does that mean? So the AB vector, which is the AB vector here, is causing a circular motion, and the resultant circular motion on this plane is having a resultant vector which is perpendicular to this motion. So you have the motion in the circular direction, and you have the thumb in the perpendicular direction to the motion. So AB vector is acting on this plane, and your resultant vector is on this direction, which is perpendicular to this plane. So it can also be illustrated with this simple diagram. You have the x-axis and y-axis. So the resultant, of the cross product is a circular motion, and the action is in this direction, which is in the z-axis. Okay, so this is defined as vector A, and this is defined as vector B. Their cross product is defined by the determinant ij, k, a1, a2, a3, b1, b2, and b3. So that would be our resultant vector. And to find the magnitude of the vector A cross B, if you plot or if you draw a parallelogram using A and B as two sides of the parallelogram, then the area of the parallelogram is the magnitude of A cross B, right? And it can be further expressed as magnitude of A cross B is equal to magnitude of A times magnitude of B mod of sine theta. So that's our definition for cross product and the magnitude of the cross product. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.